Hi future doctors, welcome to the next class. In this class we will discuss about gravitational potential energy. So why we are writing potential energy as mgh and gravitational potential energy as minus gmm by r. And you may get one doubt whenever you are applying total energy. In previous video we discussed law of conservation of energy. In the total energy we wrote kinetic energy plus gravitational potential energy. But if you have seen work energy, those lessons, total energy in circular motion also, we wrote kinetic energy plus potential energy. Potential energy we will write generally mgh. So how this formula and this formula are going to become equal, we will see in this class. So this is a planet of radius r, mass m. So on this, if you are taking any object at A, so what is the gravitational energy formula? Gravitational potential energy. So minus gmm by capital R. Mass of this object is smaller. So if you are rising to small height h at B, so what is the gravitational potential energy at B? So what is the radius of this? Small r. So U is equal to, this is A, this is B, minus gmm by, from center to here, what is the total distance means? R plus H. This one only we can write minus gmm by R, because sometimes they will give from its center they will give. At that time you have to take minus gmm by R. But potential energy, whenever we are doing, we will write simply mgh. So first of all, what is the work done to bring this object from A to B? Whenever we are bringing from A to B, it is at rest, we will assume it is at rest. Velocities are going to become zero. Slowly we are rising. Therefore, here it is at rest. Rest means we will not take kinetic energy. Then what is the work done means? Work done is equal to UB minus UA. Final energy minus initial energy. What is the final energy here? Minus GMM by R plus H. Minus. So what is the initial energy here? Minus GMM by capital R. Understood? So minus into minus plus. If you write GMM by capital R here, minus GMM by R plus H. What is common here? GMM is common. So 1 by R plus 1 by minus, not plus. So minus it is going to be. If you write plus, it is going to become wrong. So GMM, what is LCM? R into R plus H. Then here we are going to write R plus H minus R. These two will be cancelled. So GMM H by R into R plus H. So in place of GM by R, what we can write? So we came to know already small g is equal to GM by R square. Then GM by R. GM by R is going to be GR. You can substitute here. G into capital R in place of GM by R. Small m H by so R plus H. Isn't it? You got one thing, that is mgh. Then how remaining term is going to be eliminated means see here. So mgh, if you write mgh, what is extra here? R. This R you can bring below. R plus H by R. So mgh by, this one can be written as R by R plus H by R. So mgh by, what you got? 1 plus H by R. So this is the work done to bring object from A to B. So their velocities are going to become 0. Just we are bringing from A to B, from rest to rest. So this is the formula we got. So whenever you are bringing this height, how much height you may rise from surface? Maximum 1 meter, 2 meter, 3 meter, 5 meters. So kilometers. So but this h is, height is always less than r. What is the radius of the planet or earth? 6400. Compared to 6400 kilometers, 1 meter, 2 meter, 5 meters or 1 kilometer is less. Therefore, whenever h is less than r, we will neglect this. That is only, we will write mgh. Therefore, this mgh formula you got from gravitational potential energy. Therefore, whenever we are doing normally, we will apply mgh. But in gravitation lesson, whenever we are applying law of conservation of energy, you have to take sum of kinetic energy and gravitational potential energy. Now, same question from surface to in a particular orbit of radius r, which you are going to get some velocity. At the time, what is the work done, they will ask. Again, how to do means same like this only we have to do, but we have to apply law of conservation of energy. How we will apply, we'll see. Now see here, they are bringing from A to B in a particular orbit. In that orbit, it is not at rest, it is moving with some velocity v naught. At the time, what is the work done, they are going to ask. First, we will take initial at A is equal to minus gmm by r. So there is no kinetic energy from rest to orbit. In that orbit, if it is rotating with some velocity. Next, final potential energy at B minus gmm by either r plus h or small r, we will write. Next, what is the kinetic energy at B? Kinetic energy at B is half m v naught square. Therefore, total energy at A, isn't it, is equal to total energy at B. Law of conservation of energy. If we are going to apply, we will get like this. Otherwise, if they are asking what is the work done, if they are asking, so final energy minus initial energy. What is the final energy here? UB plus KB. What is the initial energy here? Minus UA. So this one we are going to apply like this. Next, what is the total energy of revolving satellite we discussed? Total energy of revolving satellite means UB plus KB. You have to take. So potential energy, kinetic energy we are going to take. Next, on this another important model, how they are going to ask means force they will give. Force is inversely proportional to some r power n. So whenever satellite is revolving in particular orbit, which force is required means centripetal force is required. So this F is directly proportional to 1 by r power n is directly proportional to centripetal force, that is mv square by r. Then they will ask what is the velocity relation with respect to this radius, they will ask. At the time, what we have to do? So v square is directly proportional to this r you are getting here divided by r power n. Then v square. So this r if you are bringing denominator, or this r power n if you are bringing numerator, that is well and good. So into r power n. So what you are going to get is directly proportional to 1 by r power n minus 1. So this is v square. Then v is directly proportional to 1 by r power n minus 1 whole power 1 by 2. Then this one only they will write velocity is inversely proportional to r power n minus 1 by 2. Also they are going to write this is velocity. Then what is the relation for time period, they will ask. So whenever object is revolving in a particular orbit of radius r with some velocity v, its time period, velocity is equal to distance by time, 2 by r by t. So 2 by r by capital. Then t is equal to 2 by r by v. Then what is r and what is v? So v already we got r power n minus 1 whole power 1 by 2. So r power n minus 1 whole by 2. So you can bring this one to numerator. T is directly proportional to, you can write r power 1 minus n minus 1 by 2. Correct? So at the time, if you have done calculation by taking LCM 2, so 2 minus n plus 1. Correct? Any wrong is there in that? You can see here. Then you are going to get in terms of radius. Sorry, here we have written V is inversely proportional, but here we have written as directly proportional. So therefore, you have to take this is directly, R is directly proportional. For V, R power n minus 1 by 2 is inversely proportional. So therefore, V is in denominator, so it is coming to numerator. So here 1 by V, how will write 1 by V? 1 by V is R power n minus 1 by 2. So we wrote it reverse. So therefore, in place of 1 by V, what we can write? R power n minus 1 by 2. Therefore, time period is directly proportional to R power 1 plus n minus 1 by 2. Then is directly proportional to R power 2 plus n minus 1 by 2. If you are taking 2 LCM, 2 minus 1, 1. Therefore, time period is directly proportional to n plus 1 by 2. R power. So simply they will give F is inversely proportional to R power n. At the time, they may ask how velocity related, how time period related. So you should remember these formulas correctly. Isn't it? So if you remember, you will be getting time period and radius of the particular orbit. If you forgot means generally you have to do by solving like this. Understood? So this is about force, velocity and time period. So radius of the orbit. So this radius we have to take, if they have given height from the surface, you have to take R plus H. They will ask what is the work done to bring an object or satellite from A to particular point to particular height from the surface. So R to 2R. 2R from surface they gave or from center they gave. You have to take care properly. At the time, what is the work done? How we will do? We will see. So what is the work done to bring the satellite or object from surface to the point which is at a height 2r from the surface of that planet or earth they are going to ask. At the time UA minus GMM by capital R on the surface. UB minus GMM by R plus, so from the surface it is going to be 2R. So minus GMM by 3R you should take. Understood? So sometimes they will give this 2R from center. At the time directly you have to take only 2R. So from this surface they are giving or from center they are giving, you have to see very carefully. Then what is the work done means UB minus UA. So minus GMM by 3R minus of minus GMM by R. So at the time, so GMM by R is common, 1 minus 1 by 3. 1 minus 1 by 3 means you will get 2 by 3. So GMM by R, 3 minus 1 by 3. Therefore, 2 by 3 GMM by R. This is the work done. So this one only they may change in terms of small g. At that time GM by R. We wrote already GM by R is GR. So 2 by 3. So GR into M. So GM by R is going to be GR. So this type of models also very important. So in this also we may apply law of conservation of energy. Sometimes in a particular orbit, whenever it is having velocity, so sometimes you require velocity also from rest to rest. This point is rest to rest. In a particular orbit of radius r which is revolving, they may set at the time UB, how you have to take means minus GMM by. So from here to here, what is the total distance? R plus 2R, that is going to be 3R plus half M V naught square you should take. Now what is the orbital velocity? V naught. V naught formula we came to know, root GM by small r. Did you remember? What is small r now? Root GM by small r is nothing but r plus 2r. That is going to be 3r. Again GM by r. We can write it as GR. So depending on the answer, how they are going to give, you are going to solve. At the time, final energy, total energy at B. So KB plus UB. This is total energy at B. So how much you are going to get total energy at B? So minus gmm by r. Total energy at B is minus gmm by 3r plus half m v naught square. V naught square means gm by 3r, isn't it? So however they are asking you should take. So total energy minus initial energy. So at the time you are going to get the answer. Isn't total energy at B, EB, total energy at A. It is from rest, therefore you have to subtract. Total energy at A is nothing but minus GMM by R. So EB minus EA you can do. Then you are going to get work done. Understood? So here, so from rest to rest means we have to solve like this. From rest to from particular orbit of radius which is rotating or revolving, they will mention in the question. You have to read the question properly. So depending on that, you have to do. So always total energy at A, total energy at B. Otherwise, potential energy at A, potential energy at B. So if you are taking total energy, that is going to be helpful because in total energy, kinetic energy, whether it is zero or it is revolving, you have to take care. So already same question on this. How they may ask me sometimes. So this is mass of the planet capital M, radius of the planet capital R. So from one particular orbit to R1 to another particular orbit R2 they will ask. So in this orbit also you will be having potential energy and kinetic energy. In this orbit also you will be having potential energy and kinetic energy. So total energy in second orbit minus total energy in first orbit. If you do, you are going to get the work done. So if it is already revolving with some velocity, then there you will be having both potential energy and kinetic energy. If you are bringing from surface of the earth, so it is not revolving, at the time you will take only potential energy. If you apply this simple logic, you can solve any type of problem in gravitation. This is important model. In total gravitation, so variation of G and next one, this law of conservation of energy and another one revolving orbital velocity, escape velocity, time period of the satellite, what we discussed now force, and last one Kepler's laws will be there, isn't it? So from this concept, otherwise from these two concepts, and from this orbital escape velocity, time period of revolving satellite. So on those three concepts, definitely you may get the problem in your final exam.